Okay, so let's start off this lesson by looking at a page in our books. This is page 11 and moving straight ahead. 1.3, raising money using linear relationships. It says, in Variables and Patterns, which is a chapter in a different book, I believe this is from 6th grade, you looked at situations that involve dependent and independent variables. In problem 1.2, the distance walked depended on the time. This tells you that the distance is the dependent variable and the time is the independent variable. In this problem, you will look at relationships between two other variables in a walkathon. Okay, so how does a walkathon work? In a walkathon, each participant in the walkathon must find sponsors to pledge a certain amount of money for each kilometer that the participant walks. Okay, so basically, you're going to join this walkathon. You're going to find someone who's going to give you money, which is probably going to go to charity. Okay, dependent on how far you walk. Now, before we do any of that, I want to reiterate or redefine what independent and dependent variables are. Okay, so an independent variable, which I'm going to call IV, okay, is a variable that represents a quantity that is being manipulated in an experiment. Okay, it's a variable that represents a quantity that is being manipulated in an experiment. Most of the time we refer to the independent variable as x. Okay, so when we see a linear equation or a formula with x, x is usually going to be our independent variable. So here's an example. Let's do blue. You do chores for money. For each chore, you make $5. Okay. So if you do chores for money or an allowance, and for each chore you earn $5, then if I think about this as a mathematical equation, the amount of money you make is equal to 5, which is how much you're getting, per chore. So if C represents chores, then 5 times the number of chores equals the amount of money. Again, in this case, the dollar sign means total earned. And then the C is the number of chores that you do. Okay. So in this case, C is your independent variable. Okay? Because that is the variable that is being manipulated. If you do one chore, you're going to multiply that 1 by 5. It's being manipulated by multiplying by 5. Okay? If you do 2 chores, you're going to multiply it by 5, it becomes 10. 3 chores, you multiply it by 5, it becomes 15. Okay? So C in this case is your independent variable. Now a dependent variable, which I'm going to call dv, is a variable that represents a quantity whose value depends that is a key term in this, depends, the dependent variable depends on how the independent variable is manipulated. Okay. Back to this example. The amount of money you make depends on, so this dollar sign or this amount of money is my dependent variable, and that amount of money depends on how many chores you do, right? Because if you're getting $5 per chore, then the amount of money you get depends on how many chores you do. If I do 7 chores, my amount of money depends on that 7 chores to become $35. If you do 10 chores, then this amount of money changes and you get $50, okay? That amount of money depends on how many chores you do, okay? Again, I would take notes on this. You should definitely know what these two terms mean, independent variable and dependent variable. If you change this in terms of y and x, you could have rewritten this as y equals 5x so that you could actually graph it. That tells me that my independent variable is x and my dependent variable is y, and I can use my x and y axes to graph these equations, and we'll talk about that later as well. All right, if you need to copy this down, pause it and please copy it down. Oops. All right, so back to the walkathon. So in Ms. Chang's class, these students are going to partake in a walkathon. Remember, you get paid depending on what you agree with your sponsor for. So here it says, each student found sponsors who are willing to pledge money according to the following descriptions. Leanne's sponsors will donate $10 regardless of how far she walks. So if Leanne walks 1 kilometer, she gets $10. If she walks 1,000 kilometers, she still gets $10. Okay, nothing changes. Gilberto, his sponsors are going to donate $2 per kilometer. Okay? That means that for each kilometer, Gilberto gets $2. And Alana's sponsors are going to make a $5 donation, meaning Alana gets $5 regardless. And then on top of that $5, they're going to pay her 50 cents per kilometer. So what does all this look like if we change them into equations? So let's look at the first one. It says Leanne's sponsor will donate $10 regardless of how far she walks. So if we're talking about Leanne, she's getting $10. Okay? Her amount of money, if we change it from L to money, is equal to $10. You could have also changed it from the dollar sign to a T for total equals $10. All of this is just for Leanne. Now what about Gilberto? For Gilberto's situation, it says that his sponsors will donate $2 per kilometer. Okay? That means Gilberto gets $2 for every kilometer. So if Gilberto walks 1 kilometer, 2 times 1 is $2. If He walks 2 kilometers. 2 times 2 is $4. Then again, you could have written this as $ equals 2 times the amount of kilometers. You could have written it as T for total equals 2 times kilometers. We usually try to make our variables something that really represents what the variable is representing. So the money sign, because it's for monetary amount, the K for kilometers, the T for the total amount of money. If we change this for something we're going to graph with, this would now become Y equals 2X. And the top one would be Y equals 10. Okay? And then finally, for Alana, remember, Alana gets a $5 donation, meaning she just gets that $5, it's like a flat fee. Okay, she's getting $5 no matter what, plus she's getting 50 cents per kilometer. Okay, so she's getting $5 no matter what, plus 50 cents per kilometer. Now, I didn't need to put that 0 there because of 50 cents. I could have written it as a fraction. It doesn't matter. So if I wanted to change this, I could have written that the total amount of money equals 5 plus 0.5 times K. I could have said that the total equals 5 plus 0.5 K. I could have said that Y equals 5 plus 5X. Okay? So these are the 3 equations that I got from these descriptions. Again, where did these come from? Remember, Leanne gets $10 no matter what. You're not multiplying it by how many kilometers she walked, because it doesn't matter how far she walks. She gets $10 no matter what. So the money always equals 10. That's what this says. This says that the money always equals 10. In the second one for Gilberto, he gets $2 per kilometer, meaning each kilometer is going to give him $2. So if he walks 1 kilometer, he gets 2 times 1, which is $2. 2 kilometers, 2 times 2 gives him $4. 20 kilometers, 2 times 20 gives him $40. Okay? And then for Alana, again, she gets $5 as a donation plus 50 cents per kilometer. Okay? This is my rate. I get 50 cents per kilometer. So you're going to, if I walk no kilometers, I only get $5 because 0.5 times 0 is 0 and 5 plus 0 is 5. If I walk 1 kilometer, I get $5.50. 2 kilometers, I get $6. Okay? That's how this works. Now, what if I wanted to represent these on a table? How would that look? All right, so let's put these on a table. I am going to erase all this and rewrite. First off, let's start with Leanne. Leanne's was either L equals 10, money equals 10, T equals 10, Y equals 10. It doesn't matter which one you use. I am going to use Y equals 10 because of my table. Makes things easier for me. On my table, your independent variable always goes on the left. Your dependent variable always goes on the right. So let's think about making a table that represents the first 6 kilometers that a person walks. Okay? So let's say that Leanne walks no kilometers, 1 kilometer, 2, 3, 4, 5, and 6 kilometers. Okay? How much does she get for each of these? If she walks 0, guess what? She gets $10. If she walks 1 kilometer, $10. 2, $10. 3, $10. 4, $10. 5, $10, and 6, $10, because she gets $10 no matter what. What about Gilberto? Gilberto gets $2 per kilometer. I'm going to rewrite this as y equals 2x. So what does that look like? If I make my table, here's my table, here's x, here's y, 0, 1, 2, 3, 4, 5, and 6. If he walks 0 kilometers, he's out of luck, he gets no money. If he walks 1 kilometer, $2, 2 kilometers, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and 2 times 6 is 12. Okay, that is what his table would look like. And then finally, let's go to Alana. Alana gets $5 plus 50 cents per kilometer. I'm going to change that to y equals 5 plus 0.5x. Here's what her table looks like. X, Y, 0, 1, 2, 3, 4, 5, and 6. Well, if she walks no kilometers, 0.5 times 0 is 0, plus 5 gives me 5. So she makes $5. She walks 1 kilometer, she gets the $5 plus 50 cents. If she walks 2 kilometers, 50 cents times 2 gives me $1. $1 plus 5 gives me 6. And then 6.50 and 7, 7.50 and 8. Okay, that is what her table looks like. So notice how I did this. All I did was plug in an input. The one I couldn't plug in an input for was Leanne's. Now, why couldn't I plug in an input? Because there was no independent variable. Okay? She got $10 regardless. In Gilberto's, my input was K or X. Okay? It was how many kilometers she walked, or he walked. And then for Alana, same thing, K or X, it was the number of kilometers that Alana walked. So I just turned a statement into an equation. We changed the equation, well, we used the equation to get a table. Now we're going to use an equation to get a graph. So let's do that. Just because it's easier to draw on here, we're going to use Desmos. Okay. First equation was y equals 10, right? We did y equals 10. And according to our table, this is our money right here. This is what we're going to use to make our graph. Our first point is 0, 10. So here's 0 on the x. Here's 10 on the y. So my first point goes right there. So if I plot that, I get 0, 10. And then 1 is technically right here in the middle. To 10, my next point's going to be right here. 1, comma, 10. And I can keep going. I've got 210. Oops. I've got 310. And I'm going to stop there because when you graph, you do not need more than 3 points. Okay? You can do 2 points, but always use 3 just to be safe. And this is for linear equations. This makes a straight line. As you can see, these points line up in a straight line. So if I took my actual equation of L equals 10 or Y equals 10 and typed that in, watch what happens. Y equals 10. It's a straight line that's going to go through all of the points from the equation. I'm going to keep that up there. Let's look at my next table for Gilberto. 0, 0. Okay? 0, 0's right here. So I've got 0, comma, 0. The next one was 1, comma, 2. Here's 1. Here's 2, so the next point's going to go there. Let's see if I'm right. Oh, look. First time for everything, right? And then the third one is 2, 4. So here's 2. Here's 4. 2, comma, 4. And I don't need anything else. I can see that these are lining up perfectly. So I'm just going to write the equation. It was y equals 2x. Notice it's a straight line. So all I have to do after I get these 3 points is take, if I have a ruler, great. If I don't have a straight edge, just connect as best as you can and make a straight line. And then finally for the third one, 0, 5. It's right here. 0, 5. 0, comma, 5. 1, comma, 550. I should probably put these in. And then 2, comma, 6. Notice how these are also lining up perfectly. So when I put these, or the equation in, y equals 5 plus 0.5x, my line crosses perfectly through those points, okay? This is what the graph looks like for all 3 of these. Now the only difference is, because this is for a walkathon and for money, your graph technically cannot go in the negatives, okay? So it's gonna look like this. It's gonna start at 0, okay, when x is 0, and then it's gonna move into the positives. We can't have these lines going into the negatives because it doesn't make sense in this context. Okay, so it's gonna look just like this. Everything starting from the y-axis and moving towards the right, staying in the first quadrant. So that's how you would graph this. Notice that these graphs intersect at certain points. There's one intersection there, there's another point of intersection there, and there's another point of intersection there. What do these points tell me? Well, we're going to come back to the graph in a second. What if I asked you, at what point are Alana and Gilberto going to make the same amount of money? Or what if I asked you, when are Leanne and Alana going to make the same amount of money? Or what if I asked you, when are Gilberto and Leanne going to make the same amount of money? You should be able to solve these all regardless. Okay? Now, I'm going to simplify this. I'm going to write down the 3 equations in terms of x and y. First one was y equals 10. That was for Leanne. Gilberto was y equals 2x. And Alana was y equals 5 plus 0.5x. Okay? Now, if I ask you, when are they going to make the same amount of money? What variable represents the money? The variable that represents the money, let's do it in green for money, is y, right? This tells me how much they get for how far they walk. The x's represent the kilometers. Y represents the money. Okay, so if I ask you, when do Gilberto and Alana, this is Gilberto, this is Alana, this is Leanne, make the same amount. Okay? This means when I ask you a question like this, that these y's have to be the same. Okay? These two y's need to be the same. So that's like me telling you that the amount of money that Gilberto makes has to be the same as the amount of money that Alana makes. Okay? Remember, Y stands for the amount of money. That's why I highlighted it in green. So again, Gilberto and Alana have to make the same amount of money. Y represents money. I'm going to write that here again. Y represents money. That was terrible. Money. So here it says the money is the same. Gilberto's money is equal to Alana's money. Well, I can't do anything with that, right? There's no numbers. However, I do know that Gilberto's Y, which is right here, is equal to 2x, meaning 2x is the same thing as Gilberto's Y. So I'm going to substitute Gilberto's Y with 2x because they're the same thing. Okay, they're the same thing, so I can substitute. It's like when I tell you that x equals 4, you can replace x with 4. Well, here y equals 2x, so I'm going to replace y with 2x. And we also know that Alana, her y, her money, is equal to 5 plus 0.5x. So here we're going to substitute with 5 plus 0.5x. 5 plus 0.5x. Oh, look, we have a linear equation. Okay? We have a linear equation, which means we can solve for x, which is what we've been doing for weeks. Right? So let's do this. 2x equals 5 plus 0.5x. Well, I only have one number, so that can stay put. But I have two x's, right? There's an x term here, and there's an x term here. So I'm going to get rid of x from the right side so that the x's are separated from the numbers. Let's put this down. Let's subtract 0.5x, which makes me subtract 0.5x. And now I've got 1.5x equals 5. Okay, I've got 1.5x equals 5. What do I do now? Well, in this case, I still have to divide by 1.5. And I get these to cancel out. And I'm left with x why is that happening? X equals 3 1/3. That is how many miles they would each walk to make the same amount of money. Okay? So when x equals 3 1/3, they've made the same amount of money. And remember, 3 1/3 is the same thing as 10/3. Okay? I would accept either answer. How do I check it? Well, when I check it, I can also figure out how much money they both make. So let's do that. Let's check Gilberto first. If x equals 10 over 3, then we've got 2 times 10 over 3, which gives me 20 over 3, which is actually equal to 6 2/3, which is about, since we're talking about money, $6.67. Now for Alana, it's 5 plus, since it's 0.5, I'm going to change it to 1/2 times 10/3. All right, so 5 plus 1/2 times 10 over 3. 1/2 times 10 over 3 gives me 5 plus 1 times 10 is 10. 2 times 3 is 6. 10 over 6 is the same thing as 5 over 3, which is actually the same thing as 5 plus 1 2/3, which also gives me 6.67 approximately. So they both make about $6.67 for walking about 3 1/3 miles. Now, what about the graph that I saw? Well, on the graph, I could have pointed this out because if this is Gilberto's graph and this is Alana's graph, they both connect right here. They intersect at this point, and I can identify that. It's 3 1/3 versus 6 2/3. Okay, that's exactly what we got over here. We got 3 1/3 and we got 6 2/3 for both of them. Okay, same thing here. If I wanted to use this graph to find the other ones, again, I would just look at where they intersect. This is where Alana and Leanne meet. This is where they make the same amount of money. 10 kilometers at $10. Gilberto and Leanne. We can also use our table to identify this. Okay? If we use our table, remember, one table for Leanne, Leanne's table looked like this. X, Y, 0, 1, 2, 3, 4, 5, 6. Here was 10, 10, 10, 10, 10, 10, 10. Versus Gilberto's, that looked like this. 0, 1, 2, 3, 4, 5, 6. 0, 2, 4, 6, 8, 10, 12. Notice where they both intersect. What is the common point? 510 and 510. Okay? So they make the same amount of money when they've both gone 5 kilometers. They both make $10. Okay? Remember, when I ask you these questions, that means the x's are the same and the y's are the same. Okay? All right. So that's it on making equations, on making tables, on making graphs, and on finding points of intersection. Okay, again, you can find the point of intersection using a table like we did here. We can use it by using we can find it by using a graph like we did here. Or we can find it by setting two equations equal to each other like we did earlier. Okay? Remember, we set 2x, well, first we set Gilberto equal to Alana, and then we set 2x equal to 5 plus 1/2 x. and then we solve this, okay? When you are solving for a point of intersection with equations, set the two equations equal to each other. That's all you have to do. And which part do you set equal to each other? Well, the part you can actually do something with. I can't do anything here, right? There's nothing to do when I have y equals y. But when I have all these x's with numbers and all that fun stuff, I can actually solve. Okay, so that's the part that I need to set equal to each other, as long as I know that this is true. If that's not true, then I can't do anything. All right, so that is it. Again, I know this was a lot. You'll have some practice problems on this. Try those out. And if you have any questions, feel free to ask.